Okay. Hello everyone. How are you doing these days? So today, as we said before, we're going to go through RAG system. I'm trying to share my screen right now. So yeah, we are going to talk deeply within the RAG system and how does it work, and why do we need a RAG system for an AI agent or something, or to build a customer service agent, for example. So yeah, we will go through these today, and we will do some practical work on N8N, and also you are going to I will give you a task so you could do it for the next time. Okay, so I will share my screen right now. Okay. So I guess it's all good. So yeah, hi again. Up to this session. It's the lecture in this training program. So in the previous sessions, we established a solid understanding of an AI agent and also the N8N. And how N8N works as an orchestrator, as a tool, etc. Also, we saw how an agent can reason, also take actions, and interact with external systems, etc. However, there is a key limitation in the large language models, with the LLMs, that can act as the brain of these systems, but their knowledge is fixed. We have, if you have been with us in our previous sessions in the previous course, you could remember that we have talked about training the LLM, so it could be up to date. It should be trained annually or like each month, so it keeps it stays up to date and not to get old, or the knowledge is getting fixed, etc. So they are trained, the LLMs, they are trained on a very large data sets. We have talked about this before also, but I will repeat it so anyone new here could also understand this. But this training happens only once, and after training is completed, the model's knowledge becomes frozen at a certain point in time, known as the training cutoff date. Because of this, the model may not be aware of recent events or newly published information. In some cases, when asked about topics outside its knowledge scope, the model may generate answers that sound correct, but are actually inaccurate and nonsense. This is known as hallucination. So to make AI agent more reliable and capable of providing accurate answers, we need to give them access to information outside the model itself. Instead of relying only on the model's internal knowledge, the agent should be able to search and retrieve information from external sources when needed. So you might give, if you want to give the chat, maybe like ChatGPT or DeepSeek, etc. If you wanted to like, I don't know, give you an information about a specific company, but this company isn't as known as you think, and the agent does not give you an answer for that. So you go to this company and you get some information from its portfolio or the website, or maybe an application of this certain company, and you give it to the AI agent. This is how it works. You get an external knowledge from external sources, and you feed it to this AI agent. So in this lecture, we will focus on how to achieve this using knowledge bases, not just copy pasting the information, and a technique called retrieval augmented generation, which is the RAG. And we will explore how to give our agent an external memory layer and how technologies such as vector database and embeddings allow the agent to retrieve information intelligently. Okay, so knowledge limitation in LLMs. So before introducing knowledge bases and RAG systems, it is important to understand the challenges related to knowledge in LLM. So the parametric knowledge, actually the information that the LLM learns during the training process is known as parametric knowledge. This knowledge becomes encoded inside the model's parameters and weights. However, the model only learns from the data that existed during this training phase. Once the training process ends, the model cannot automatically learn a new information. And because of this, there is always a cutoff date for the model's knowledge. Any events, research, or data created after that date are not known to that model. As a result, the model may struggle to answer, it will hallucinate, etc. So hallucination, let's talk about hallucination. Another challenge, it's another challenge that happens when the model produces an answer that appears coherent and confident, but it is actually incorrect or fabricated. So hallucinations can occur for several reasons. The model is designed to generate fluent text, even if it does not have enough information to answer accurately. It may also generalize patterns incorrectly from the data it learned during this training. One second, please. Okay. So where were we? Okay. So also, in addition, if the training data contained contradictions, the model may produce inconsistent answers. So these hallucinations can create serious problems in real applications, including loss of user trust, for example, incorrect decisions based on inaccurate information. I guess you have seen some influencers or some like famous people getting online and saying that they lost some money, they lost some of their belongings because they relied on a ChatGPT information without returning to the real the real source or the up-to-date source. So they relied on the ChatGPT, let's say, for example, knowledge, and its knowledge wasn't up to date, and it didn't have a good amount of information about this specific subject, so they lost some money or something. Okay, so also we have difficulty of updating and customizing knowledge. Updating the knowledge of a trained LLM is not straightforward. In many cases, the only way to update its internal knowledge is by retraining the whole model with the new data. So retraining is extremely expensive in terms of both computational resources and also time. It is also difficult to customize a general purpose model to work with private company data or specialized domains without going through a complex and costly retraining processes. So yeah, this is the whole challenges that we have in LLMs, and that's why we will go to use external knowledge bases and RAG systems. Okay, so external knowledge bases to overcome the limitations of the LLMs, we introduced the scientists introduced the external knowledge bases. So instead of storing all knowledge inside the model itself, we store information in external systems that the agent can access when needed. So a knowledge base can exist in different forms. Traditional relation databases such as MySQL or Postgres, SQL, they are used for structured data. Also, we have document databases like MongoDB. They are often used for unstructured or semi-structured data. And many organizations also store information in content management systems, such as like WordPress or SharePoint, or in file storage platforms like Google Drive or Amazon S3, etc. However, for AI agents and RAG systems, the most important type of knowledge storage is the vector database. So, if you remember at the beginning of this course, we have seen vector database, and we have called it a specific database for the AI agent that only AI agent can understand. So the relational database or document database or content management one, or even a file storage, these all are for human reading. But if we want the AI agent to understand the information or the knowledge base, it should be a vector database. So what is a vector database? How does it work? So they are designed to store and search vectors, which the vectors are numerical representations of information, such as text, images, audio, anything. So they are the machine or a computer does not understand a word like, let's say, hi. 1 second. Okay. So it does not understand hi. It does not understand if you send it a voice message or an image or etc. So what it does, it will reform this voice message or this text message or anything to a numerical value, which is called a vector. So it looks like this. A vector kind of looks like this. So let's say, for example, each number in this set, there is a set. So this is a vector, and each number represents a specific parameter of this text or this voice or this image. So maybe a -111 means 122 means that this word is related to, let's say, medicine or anything else. And in voices, there are like other parameters that are related to voice itself. And in an image, there are some color parameters, etc. Okay, so each piece of content is converted to a vector, and then it is placed in a high dimensional space. So items that are semantically similar appear closer to each other in the space. So there is a space of this the dimensional space. So in this space, each number means something. So if we say a queen and a king, so these are semantically similar, but they are different. So a queen is for a female, is a female that has power over kingdom, and a king is a male for the same word. So they are close enough in this dimension, but they are not the same. So the AI agent can understand what each one means. So let's talk about how does it work. So first, pieces of information such as paragraphs or documents are converted into vectors using an embedding model. So first is embedding. These vectors are then stored inside a vector database. And when the user asks a question, the question is also converted into a vector. So we have a query from the user. This query is also converted into a vector. So what does this mean? This means that embedding actually works for your own information, your own document that you want to vectorize it, or tokenize it. And the query itself, the user query, is also using embedding systems to convert to a vector. So when a user asks a question, the question is converted to a vector, and the system then it searches for the vector in the database that for the words that are most similar to the question vector using similarity metrics like cosine similarity, etc. These are all mathematical information that AI uses. So finally, the system receives the original text associated with those vectors, and then it will reform this vector into the NLP, the natural language that you understand. If it was English, if it was Arabic, anything else. Okay, so for examples of commonly used vector databases, there are some something like Pinecone. You could search for Pinecone, Weaviate, Chroma, and other databases. So you could search for these, and I personally use Pinecone because it's free and it's really easy to use. I use it with N8N. Okay, so let's talk about embeddings, how we turn words into numbers. So embeddings are a central component of RAG system. They allow us to transform words, sentences, and documents into numerical vectors that machines can analyze and compare. So an embedding is essentially a list of numbers that represents the semantic meaning of a piece or of a text. So texts that have similar meaning, they will produce vectors that are close to each other in the embedding space. So this is the embedding space, and as you can see, if we have like really similar words, you will see them closely to each other in this spatial space. So they are the embeddings. They are generated using specialized models like such as OpenAI, or also OpenAI embedding models, or open sources models like SentenceBERT, etc. They are all the some AI. What's it called? We use BERT a lot for text and speech in AI. So some open sources models will be SentenceBERT or an API text embedding. Okay. No, we haven't finished here. So let me tell you about something called chunking. I'm sorry. In practice, large documents are first divided into smaller segments in a process known as chunking. So it is like the name. For example, there's a long document that may be split into segments of a few hundred words with small overlaps to preserve context. So I will show you how does this work in N8N. So each segment is then sent to the embedding model to generate its vector representation. These vectors are stored in a vector database together with the original text segment. So embeddings make semantic search possible instead of searching by keywords, and the system actually searches by the meaning of this word. So this is why it makes the AI better than a fixed agent. It will search by the meaning and not by a specific keyword. It will choose the best, most close, semantically alike the word in their own database or own spatial space. Okay. So by retrieving irrelevant information and providing it to the model as context, embeddings help reduce hallucination, and it allows the system to use updated knowledge without retraining the whole LLM. So this is how we use, or this is the beginning of using a RAG system. Okay, so this is the chunking over here. The data source, whether it was a text or an image or a video or a voice, it will be split into some chunks. Then the embedding models will generate embeddings for these or vectors for each chunk of this data source, and then it will store it in a vector database. So first comes the chunking. It won't vectorize the whole document as once. It needs to chunk it as first, and then it will convert it into a vector database using an embedding model, vectors using embedding models, and then it will store them in the vector database. Okay, so let's talk about RAG system. So it's actually called Retrieval-Augmented Generation systems. It is an architecture that combines the generative abilities of the LLM with the factual reliability of external knowledge sources. So what do I mean by this? In a typical RAG workflow, the process happens in three main stages. The first is retrieval, and then the augmentation, and then the generation. So what is the retrieval? So if we could, okay. So the retrieval, when the user asks a question, the system converts the question into an embedding vector. We have seen this before. Okay. So when the user asks the question, it will be converted to a vector and then searches the vector database for the most relevant pieces of information. So second is augmentation, which is the retrieved text. It is segments, the retrieved text after being segmented, they are inserted into the prompt that will be sent to the language model. This means the model receives the user's question together with the additional context extracted from the knowledge base. So this is how it happens. It will have an external knowledge from a vector database. Third is generation. The language model uses both the user's question and the retrieved context to generate the final answer. And because the model is grounded in real documents, the answer becomes both fluent and factually supported. So this approach provides several important advantages. It significantly reduces hallucinations, allows the agent to access up-to-date information without retraining the model, and make it easy to customize the agent using domain-specific or company-specific data. But however, RAG systems also, they introduce, so RAG system introduces new challenges. The quality of the retrieved information directly affects the quality of the final answer. So the context window of the LLM, it is limited, right? We have talked about this. So only a certain amount of retrieved content can be provided to the model. Also, additionally, the implementing RAG requires managing embeddings, vector databases, and also orchestration between multiple components. So it needs some work. But however, in a generalized, it is much better, much faster, and much cheaper than using or than retraining a whole model. So how do we integrate or how do we implement RAG system within it? So the question becomes how the implementation works. These these ideas, the implementation or the vectorization, how do they work in practice? So this is where N8N becomes extremely useful because it can orchestrate the entire RAG pipeline. In a practical system, an 8N can handle the process of collecting data from different sources such as PDFs, web pages, or databases. Once the data is collected, it can be processed and split into chunks. These chunks can then be sent to an embedding model using an API call inside an 8N code node or inside the RAG node itself. After embeddings are generated, the vector can be stored inside a vector database like a Pinecone or a Chroma. And later, when a user asks a question, N8N can convert the query into an embedding. Then search the vector database, retrieve the most relevant chunks, and construct the final prompt that will be sent to the LLM itself, or the language model. Okay, so the language model then generates the final response using the retrieved information as a context. And another powerful pattern is exposing the RAG flow as or RAG system as a tool that an AI agent can call when it needs, or when it needs a reliable knowledge. So in this setup, the agent decides when it should use the tool. So we have here a root node and a subnode. So it will decide which one to use. If the agent receives questions that requires accurate or domain-specific information, it can call tools such as search knowledge base and pass the user query to it. The tool runs the RAG workflow in N8N and retrieves the relevant information and returns the result of the agent. But in 8N, it can also automate the continuous updating of the knowledge base. So for example, it can monitor a Google Drive folder. So it can automatically update the knowledge base by monitoring and extracting and also embedding and also indexing. So I guess we have finished over here. Let's go on and I can't see what am I sharing right now. Is my N8N workflow present for you? Can you see it? Okay, great. Thank you so much. Okay, so we will see this RAG system over here. I will just refresh for a second. So this is how a RAG system would look like in N8N. So let's say I want to apply all the information that I just said for you, or like explained. Let's talk about the talk about something called Jobot. So let's say that Jobot is a specific company that the agent, like OpenAI, which I'm using over here, and just over here. So if I'm using OpenAI and I know that OpenAI does not know what Jobot is, so I will show you what Jobot is. This is Jobot. So it is an intelligent automation company. They have a specific introduction of themselves and what they do. They have some specific things like Jobot AI reply agent. They represent and they are saying in this file what are they doing, and at the end they say that they have this email and they have this website, they have this the availability for it. So it has some information about this specific company. Okay, So I want this agent to be able to answer about Jobot. Because if I go and ask ChatGPT what is Jobot, it wouldn't understand what I mean, and it wouldn't answer a specific and accurate answer. So we have an upload file node over here. Okay, so just 1 second. Yeah. So yeah, we have an upload file node over here. So what does this file, what does this node do? So it creates a simple web form that accepts it. It is the trigger, as you can see. There are no input circles here. So this is the trigger. So it accepts a PDF or a CSV file. When you submit this form, it triggers the entire ingestion flow. In our case, we are uploading the Jobot company document. So all the information about what Jobot does, its services, platforms, and how they work, it's all inserted into this node. This is our starting point, that nothing would move unless this one does. So once the file arrives, this node, it reads the raw binary content of this file. Let me show you. So I want to start and execute the workflow. Okay. Have you seen the pop-up that has appeared right now? Can you see it? This pop-up? I guess not. Yeah. Okay. So let me adjust the sharing. Okay. So I just shared my whole, okay. So if let me stop this and execute the workflow again. So let's say that I want to choose a file over here. So I will choose a file, and let's say that I want to choose a specific file called Jobot. So I will choose Jobot over here and then submit this workflow. It said form submitted. Thank you so much. And we can see the whole green that represents a workflow that has been successfully running. Okay, so I will reshare the specific. Okay, so as you can see here, this node here, it received a binary file. This file, it has some information, the name, the extension, etc. So once the file, it arrived, the node, it read the raw binary content and converted the file into text that the rest of the workflow can process. So it basically opens the file and says, here is what's inside it. And without this node, the file is just a blob of bytes. The workflow wouldn't understand. So next, we have embedding OpenAI. So we used an embedding node. This is a node that uses OpenAI. So this is where the theory we covered becomes real. So this node takes the text from the document and then sends it to OpenAI's embedding models. As you can see here, this is the embedding model that this node is going to use. So it comes back as a vectors. When the documents are sent to the embedding OpenAI, it will come back as a vectors. As you can see inside this node, we can see that it used the model text embedding 3 small. And as you can see here, this is our vector. As you can see here, it showed it retrieved the whole document. This is the input over here, the document, and it transformed them into vectors. And as you can see here, vectors are a lot of data, let's say, for example. And each one of these vectors they represent something. So this might represent the Joput intelligent automation. So it represents a specific word or a bunch of words. So this is what happened here with the embedding OpenAI. And this node is the default data loader. It will load or store these embeddings into the database or the vector database. So this is how it works. This node used an embedding system, and it used a document or a default data loader to store them into a vector database. So as you can see here, this is our vector database. We talked about what's that word? Chunking. So this is how the chunking worked. So the embedding batch size is actually the chunking, and we said 200. What do we mean by 200? If we press here, it says number of documents to embed in a single batch. So this is the number of each, let's say, bunch of words that are going to be embedded together or in a single chunk. So the single chunk will take 200 words, for example, and then it will store them together as one chunk, as one row in this vector database. So why do we do this? So I will tell you about this later on. So if we have seen that it has been successfully created, we have this next workflow here, which is retrieve flow. In this workflow, we will use a chat node. We have seen this before. I will ask it, what does it know about Joput? What do you know about Joput? As you can see here, it's running. It's using an AI model. And also it is using or querying the database, the vector database, while embedding our own query. So we have the embedding works in in multiple steps. The first one for embedding or vectorization for the specific document, and also when we want to convert our own query, which is this one. What do you know about Joput? It used the embedding to convert it into a vector, so it could understand it and do some semantic semantic search over this database. So as you can see here, the answer was correct. Joput is an intelligent automation company focused on helping businesses streamline, etc., etc. So they gave me the whole information. And also, as you can see here, they retrieved the specific website and the specific email. While if you went and answered and asked a ChatGPT or a DeepSeek, it wouldn't give you this specific answers. Okay. So yeah, as we can see here, let's open this data tool over here. So this is actually a tool that the AI agent must know when to use it. So as many tools, we need a description for this one. So the description is use this knowledge base to answer questions from the user. And I might actually say that to use it only when asked about Joput. If I don't want it to vectorize each input of the user each time, because sometimes it will ask a general question. And if I want to specify this agent for my own company, I will not use this one. Okay. So yeah, from the memory key. So this is the memory key or the vector database that we have. It is a simple database. You can use Pinecone or Chroma or anything else. But in an N8N, it helps you by providing this vector database that they have. it's really simple. It doesn't work on production level, but it is like for testing and trying, etc. Okay, so this is how it works. I guess it's really easy. It may be difficult to understand, but to understand the technical parts inside and how does the vectorization work? How does the embedding work? So these all are really technical knowledge that you can get through studying thoroughly into mathematics and AI, especially in machine learning and deep learning, and also NLP. But in general, it's really easy to use when using N8N, because N8N helps you, and it is a low-code platform. It really helps you even when you don't understand the whole picture. And also, you won't understand the whole picture because the AI is also still a black box that we don't understand the specific and how specifically it works in the LLM. Okay, so this is everything, I guess. We have or you have a task to do for the next time. So the next time I want you to be able to build a workflow. So the workflow, it should consist of a rack system. You could choose whatever input that this rack system should have. It doesn't have to be this specific node. It could be a webhook node, or a Google Drive node, or a document node. No, this Google document. It could be a Google Docs. So whenever there is a create a document, this workflow will run. Or you could have a folder of your own on your Google Drive. There are multiple and many ideas to start this workflow. So I want you to be able to start a workflow using anything in this world, and to build the whole rack system from scratch. You can use some help from the internet, from YouTube, from other sources, but I want you to practice with your own hands, and I want you to like search for nodes and to see what N8N has, like what nodes that I can use to make this better. Can I use like a pinecone instead of, so can I use a pinecone vector database and get and add and retrieve and update data, whatever you need, whatever idea you want. But I want you to build this rack system. This is a task for the next time, and I guess there will we will tell you how to submit it, or maybe you will just submit it in the next session. So I just want you to build it before the next session. It should have a rack system and a chat system, or like a chat workflow. It could be WhatsApp, it could be chat trigger, or maybe Telegram. So I would recommend Telegram being the easiest if you want to use something other than chat trigger. Telegram is really easy to use. So yeah, you will build a rack system and a chat flow and add any tool you want, fix it, and just build something incredible. So your hand would really get the hand of the innate. So that's it. Thank you so much for joining. I think it was a good session. Please tell me, and please tell us in the forums as well at the end of the session. Rack system is really, really important, and it's needed for the big companies. Also, the companies that don't really know how to build agents of their own. So if you have any questions, please go ahead. If you don't, Jaya, I think we are good to we're good to go.
Sure, Myra.
Thank you so much.
Thank you all for joining. That was a great session, Myra.
Thank you.
Thank you all.